stuff. Sound good to you guys? So we'll work off the MCQ and FRQ selection. Okay. Oh my God. The MCQ and FRQ collection in the OneNote. Everybody's okay for test 3? So if you wanted to follow along on your own tablet, that's fine. I'll project it up here, obviously also, no big deal. After we've done that, we'll do that for a half hour or so, and then we'll return back to the 3-9 stuff that we started on and do a little bit of that. Cool? Okay. Let's see. Yeah, when's the test?
Thursday.
Wednesday, Thursday next week, right? Right. So yes, okay. And I want to be here. Yes. Okay. So today, let's oh my goodness, what happened? Come on. So let's, we'll do some MCQs today. We did an FRQ last time. Sound good? Okay. And I'm just going to kind of cruise through and stop at things that I feel like are maybe an unusual presentation compared to what we've been mostly working on. Did you guys get what I say by unusual presentation? Okay. So like something not like these guys, which are, you know, like the same kind of stuff we've been doing over and over and over again. So I'm just going to kind of scroll till I see something, you know, like this, where it's like, oh, that's a different presentation. It's just not like an equation. Say, take the derivative of it. It's given you, it's a little bit more abstract. We have a table, etc. Cool? All right. So it says selected values of the increasing function h and its derivative h prime are shown in the table above. If g is a differentiable function such that h of g of x is equal to x for all x, what is the value of g prime of 7? Okay. What is the key piece of information given to us here in this problem that tells us how to start? Excellent, 100%. What does that mean? Yeah, oh my gosh. Someone help her. Yes. And because they're inverses, we know we can write that g prime of x is equal to 1 over h prime of g of x.
Do you have to memorize that specific for the test?
Well, it's the same thing you'd get if you took the derivative of both sides of this and then like solve for g prime. So no, but I would, because it's just easier than having to do the extra rigmarole. Is that okay? Okay. So if I want g prime of 7 then, that means I'm going to do 1 over h prime of g of 7. So far so good? What's g of 7? The table only has h's in it. Is this a mistake? How am I going to find g of 7?
G of 7 is h x.
So it's not a mistake.
Inverses, so you take the.
Yeah, that's exactly right. That's the key. I was this many years old when I found out you can do this. So what does that mean? Well, if we have like 3 and 7, h sends 3 to 7, and then it sends 7 to 5, right? Everybody agree? Because they're inverses, G is going to send 7 back to 3 and 5 back to 7. So what is G of 7 going to be? 3. And then H prime of 3 is 5. Very sneaky, Mr. Kool-Aid. If you're not having seen that before, to catch that like, ugh, I don't have G of 7, how do I get that? To be like, oh, I'm going to use what I know about inverses to be like, I know it's just the backtrack from H of 7. You see it.
So if H of 3 is equal to 7, then G of 7 is equal to 3? That's
Yes.
basically what that is. And
Yes.
Is that the same thing for prime? Like H prime of 3 is equal to 7?
You cannot make the same argument for the
Okay.
derivatives. Because we don't know that the derivative of H and the derivative of G will be inverses.
Right.
That we don't know. And in fact, probably not. So far, so good? You guys feel good? Okay. Again, quite tricky, right? Having seen this trick before makes it much easier to spot the next time. But this is, I would say, is like, in terms of obfuscating the given information that you need to complete the problem, this is in like the top tier of, we're going to be really sly about giving you what you need without really telling you we've given you what you need. Those are all normal. Let's do 16. That's a good one. All right. 16 says the graph of the function g is shown above. If the function given by f of x is equal to g of x, what is the value of f prime of 0? How would I start? I would start by finding a formula for f prime. Now, eventually we're going to need to know what g of 0 is. But I think the first thing I want is, if I want to know about f prime, let's find f prime, right? So what's the derivative of g of x? It's a chain rule. Very good. It's not inverses, right? Nowhere in here are we told that g is an inverse of itself. In fact, it's not. Okay? Because we don't have g of x is equal to x. This is just a regular chain rule problem. So the derivative is going to be
G prime g of x times g prime.
perfect. Everybody feel good? Now, if I want f prime of 0, we can do that. Now, Sarah definitely said at the beginning we need g prime of 0. Let's get it. What is g prime of 0? Or I'm sorry, what is g of 0? Just g of 0 is 3, right? And then we have to find g prime of 0. What is g prime of 0 going to be? It's the slope right over here, right? So it's going to be, and that's true for x equals -2 to 1, right?
How do you know that it's a slope?
Because it's a straight line.
So,
Right? That part of the graph is straight line. So the derivative of a straight line is just slope. Right? If I have like y equals 2x, that's a straight line. The derivative of 2x is the slope.
Okay.
Perfect? Yes, we're good? Okay. So I can do that, right? That's just y2 minus y1 over x2 minus x1. And then g prime of 3. How am I going to do that? Same thing, but where am I taking the slope at?
3.
Here, right? So from 1 to 6, I can use that slope for the derivative of anything, right? And that's just going to be 2 there, right? 6 over 3. And then that's going to be -5. We've made a -1, right? So we have that. Everybody feel good as to what we did there? Again, notice that I'm not bothering to complete this. Like once I see what the answer is going to be, I'm just going to stop writing and circle my answer and try to save myself 10 or 15 seconds every place I can, especially if I'm practicing for an AP exam, or like the time I don't spend on this question that I know the answer to, or I've seen where the answer is going, this time I can spend on some other question like that I really have to sit down and think about, or like there's no quick way through this. I just have to like grind through like a bunch of symbol push and then do some simplifying at the end still. Yes, Brooks.
What was g prime of 0?
So over here.
Oh. Okay, sorry. That look.
Oh.
Okay.
That's okay. All right. Let's do this guy. So 18. The table above gives the values of differentiable functions f and g and of their derivatives, f prime and g prime, at selected values of x. If h of x is equal to f of g of x, what is the slope of the graph of h at x equals 2? What do we ask to find here? Okay. Right, that's what we're looking for. Everybody agree? Okay. How do we should do first to find that? Yeah, let's find a formula for h prime of x. Perfect. What's the derivative of h prime of x going to be?
F prime of g of x.
Teamwork. Overlapping where I couldn't understand anything anybody was saying, but that's okay. I think all the right words are coming out of our mouths. Everybody good? So if I just plug the 0 in, g of 0 is 1, right? Everybody agree? G prime of 0 is, oh, I'm sorry. I circled the wrong thing. G of 0 is 0. Woo! G prime of 0 is 1. Yikes. Got to be careful, right? Now, f prime of 0 is 1. And I have the wrong answer. Oh. G prime of 0 is 1. G of 0 is 0. F prime of 0 is 1. Oh my God, we are supposed to be plugging in 2. Great googly moogly. Should have written it in here. Golly! Criminally, no wonder. Thank you. All right, G of 2 is -1. G prime of 2 is 2. F prime of -1 is 3. 3 times 2 is 6. Woo! Makes me feel a heck of a lot better. Thank you. That's a classic Mr. Kulik mistake, right? Doing the problem exactly right, except you put the wrong number in. You do a pie chart of the reasons I make mistakes. Like reading the problem wrong is like 2/3 of the mistakes. And I have like another 20% is going to be like copied something down wrong. All right, let's do 19 along the way. This is a good one also. It says the graph of the function f consisting of 2 line segments is shown in the figure above. Let g be the function given by g of x equals 2x plus 1, and h the function f of g of x. Find the value of h prime of 1. What should we do? Start by finding a formula for h prime of x, which is lovely. Okay. So now we're going to do h prime of 1. I'm going to write it down this time so I don't forget. How do I do g of 1? Oh, yeah. So what do I get? 3. And then I need g prime. What's that going to be? Or g prime of 1? It's going to be 2, right? Because g prime of x is just 2. Right? It's a constant function, so like it doesn't matter the 1. It's still going to be 2. So you look upset by that.
It's 2 because the derivative of g is just 2. It's in the equation.
Oh.
We're using that guy. And then f prime of 3, how do I do that? Yeah, right? So what's the slope there going to be? (6/3) or -6/3, right? So -2.
You took the AP exam, would you get $100?
No, I would read some problem wrong and get something wrong because I did something stupid. I think I'd get a 5. I'd be really embarrassed, like unbelievably embarrassed. But I'd be really upset with I'd just be like, but I don't think I'd get 100% just because I do stupid stuff because I get going too fast.
Yeah.
The biggest thing for me would be like, take a breath and slow down. You're going to be fine on time. Like, you're not going to run out of time, Mr. Kulik. Stop trying to show off or whatever. Because I'm working on it, though. All right. A couple more. You guys sound okay? Okay. Why don't you guys try 20? We'll take a couple minutes, let you guys think on this, see if you guys can get 20. And then we'll go through it as a group after, I don't know, like 2 minutes or so. That's the standard pace that you should be working on the no calculator problems at to finish the AP exam. You have 30 questions to answer in 60 minutes. So these no calculator problems should be about 2 minutes a problem, which is not the pace you guys are going at on the exams when I give them in class.
A little bit longer, do you think? Just a little bit.
Just a little bit.
A lot longer. Takes me like 7 minutes when I say it.
But hopefully you're seeing that, like, this is the place to prepare for the multiple choices. Like with these multiple choice questions I'm giving you, oftentimes you're going to see it's the same problem just recycled with like different numbers or like a slightly different setup. Like that previous problem, your g of x might be a slightly different function, but it's ostensibly the same problem. Does that feel okay, guys? In terms of preparing for the multiple choices, like I gotta spend some time on these because you're gonna see the same tricks recycled again onto the test. That hasn't become apparent yet. I'll emphasize that that's a really good, effective place to spend some time preparing. That's been about 2 minutes. I know. Well, I was talking over it too, and you're like engaging with my talking, so I'm sure that didn't speed anything up yet. Well, this is the key. Right? What does that tell us?
So that means f of 3 is 15, so g of 15 is 3. But does that matter at all? Yeah, because then you put 15 in there at the bottom. Because g of 3 is 15. Because, wait, g of 15 is 3. G of 3 is.
Where'd you get that
G of 15
equation?
is 3.
That's for inverses.
The inverse is just it divided by.
So it's negative 1.
So we take the derivative of this.
Yeah. Oh.
And then we divide both sides by the composition. I'm just using this as a formula to shortcut through having to do that algebra every single time.
Okay.
Because as soon as I see two things are inverses, that's the derivative relationship I probably need. So I'm going to treat that like a formula.
Thank you.
And f prime of 6 we have. Why am I saying g of 3 is 6?
Because they're derivatives, or they're inverses.
Yeah. So f does this, right? Because g is the inverse, it's got to take 3 back to 6. Again, same trick as that one we started with, right?
Oh. Kind of good.
This was the key to starting though, right? You don't notice that the inverse, that the two things are inverses, implies that you need that derivative relationship. It'll be slow going. Very good.
What's the point of writing out like the thing you did to the far right if it's all given to you like at the top? Like, do we even use that rule?
So that is justifying this.
Oh, okay.
In fact, it's really just that part of the picture is justifying that statement that I made up there when somebody said, what's g of 3?
I get it now. Okay. Thank you.
Yep. Now, Lucia, g of 15 would equal 3,
Yeah.
but that's not what we want, right? Not the other way. Or if you prefer, you can think about it this way. You have like f of 6 is equal to 3. If you do g of both sides, because these are inverses, it's just equal to x. Right? The definition of inverse is so that's what we have here. So it's just equal to x. So you think about it that way too if you prefer. I like the map. The map to me makes so much sense. It's just like, whoop, going one way, and takes it back.
Yeah.
That's what I like. I'm a visual guy. I think that makes easier conceptual understanding. But if you're like a symbols person, like that's what you're doing. It's the same. It means the same thing. We're doing the same process as the map. I like it. Is that good?
Yeah.
Okay. Scrolling through, looking for things that are like kind of unusual presentations. Well, let's stop and do this one. This will be fun.
Can I ask a general rule about inverses?
Sure.
So it's
Start working on this one. Brooks asked this question. Okay, go.
multiple multiple x's can have. Is it multiple x's can have one y value, or multiple y's can have one x value?
Multiple x's can have the same y value, but not if their inverse is a function.
Okay.
So if their inverse is a function, that won't happen. F would have to be 1-to-1 for F inverse to be a function. Actually, it has to be 1-to-1 and onto
Okay.
for it to be a function over the same stuff.
Just check.
So yeah, that's a worthwhile question. Now you can still do it, but now there's two possible outputs for the inverse
Yeah.
if it's not 1-to-1, which makes life kind of a headache. When we have encountered functions like that before, like the sine and cosine function, remember to make sine inverse and cosine inverse, we restrict the domain so that it covers the whole range of the function, but we remove the loss of 1-to-1, we remove the repeating y coordinate, so when we make our inverse, it's a true function.
Okay.
But that's why when we solve inverse trig functions, you have to like draw the picture and sometimes like add or subtract some multiple of pi or 2 pi to your answer to get in the quadrant you're looking for.
Okay.
Because you're not actually dealing with a full inverse function, you just have like this little chunk of it.
Yeah, I get that. Thank you.
Sorry, I jibber jabbered over while you guys are working, but it was a good question, you know, like that's an important, like remember this from inverses moment, since we've been talking about them. Ooh. I'm going to start writing because I don't know the answer to this square away, at least just by looking at it. That's supposed to be 6.
Why is it 6? No, it's not.
Oh, yeah, 6. That's, sorry. Right. And that's the same thing as this guy. For sure. But this is the kind of stuff you guys should feel the most comfortable with, right? I haven't stopped and done a lot of these guys because it's basically just the pieces that I know that we've spent the most time in class on, we've done the most practice on, so I'm intentionally avoiding these because I feel like these are things you can try on your own, and it's unlikely that, like, even if you get it wrong and you go back and look at the answer, that you won't be able to figure out like what your mistake was. The other ones where it's like, I don't even know what to do with this because there's nothing given to me that I can just like take the derivative of symbolically and get like a normal answer or push some symbols around. Yes, you see that?
So when you were taking the derivative of the 2xy, like near the product rule,
Yes.
you got rid of the y and the 2x and made it dy dx.
So this part was 2x times the derivative of y, and then this part was 2y times the derivative of x. So the derivative of y was 1 dy dx. The derivative of x is just 1.
Okay, so then why did you keep the 2y dy dx there? Like the last one.
Because the derivative of y squared is 2y dy dx. Because again, y is not with respect to x, right? Is that okay? Yeah or no?
Yeah.
Yes, ma'am. Sure. I think at this point we're going to change streams here and go to section 3.9 and pick up where we left off over there. Everybody okay? Again, over the weekend as you're preparing for test 3, spend some time here, right? We've done a ton of practice for the symbolic problems. You should feel the most comfortable if I say y equals yada yada yada, take the derivative of this. Those should be the ones like, let me see those, let me add them. I'm ready to do that. We practiced with the G side of those. And the ones we've done are going to be, remember the packet, or the last page, way harder than what you'd see on the test. So you should feel real ready for those. What I'm more concerned about with the practice now is these ones that the textbook doesn't have a lot of problems like these. You know, I want to make sure we get the practice in. And you should spend some time doing that. All right. Today, we're going to pick up on this water tank problem. So just to reread what we have done so far. A water tank has the shape of an inverted circular cone with a base radius of 2 meters, height of 4 meters. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. So we drew ourselves a picture of our inverted cone. We observed that there's really 2 cones present, one that's the shape of the tank, and one in the shape of the water filling the portion of that tank. We labeled some parts of our cone for volume of the tank, radius of the tank, height of the tank, volume of the water, radius of the water, height of the water. We observed that the tank variables are constants because the shape of the tank will not change with respect to time. And we notated that the water variables are variables because they are changing with time. The volume is increasing as water comes in. The height's going to change as water fills the tank. The radius changed because the top of the cone is now at a different location with a different radius. Then we went through and labeled the numbers given to us in the problem. We said that the 2 meter was the radius of the tank, 4 was the height of the tank, the dV, W, dt was the 2 cubic meters per minute rate, and we're looking for the dHW dt when HW is 3. Everybody cool with that? The next step in our process is to find an equation that relates our variables with respect to time together. Hopefully the obvious choice is the volume of a cone formula. Does anybody remember the volume of a cone formula?
4/3
That's a sphere.
pi r squared.
So the volume for a cone is 1/3 pi r squared h. And since we're talking about the water and not the tank, I'm going to put the water subscripts on there. Everybody's okay? Is the expectation that you have these semi-obscure volume formulas memorized? No, I would probably give you a volume one. A area? Yeah. A Pythagorean theorem? Yeah. A trig relationship? Yeah. Everybody's okay? But some of these volume ones, like the volume of a sphere, volume of a cone, or a pyramid, volume of a box, probably expect you to have that. What's the volume of a box? Length times width times height, but a square or a cube. Side cubed, right?
So length times width times height.
Same thing as length times width times height, right? Because they're all the same. Because it's a square cube. Of course. All right. We have our formula. What do we do next?
Plug in Charlie.
No. Calculus time. We have not done any calculus yet, believe it or not. We take the derivative with respect to time of both sides. What's the derivative with respect to time of VW? One dVW dt. I'm not going to bother with the 1. Right? Is everybody okay? Then I have, I'll pull out the pi over 3, or the 1/3 pi. And then what, what do I have to do do the derivative of the other side?
2.
Product rule. Who saw it? That's good. 1 of 20. Beep. Do you see where the product rule is coming from?
Yeah.
2 variables multiplied together, right? RW, HW, product rule. All right, so we're going to have pi over 3 RW squared times the derivative with respect to time of HW plus pi over 3 HW times the derivative with respect to time of RW squared. So I wrote out the product rule steps, so if you go back and look at this again, it'll be obvious what I did to go here, since a lot of us missed that there's a product rule going on, which is fine for now, but come Tuesday, Wednesday, or Wednesday, Thursday next week, it's not fine. Got to be on it. Everybody on it? Put it on your list. Watch out for those hidden product rules on these implicit-ish differentiation problems. I'm going to try to catch you with forgetting about it. Okay? All right. What's the derivative of HW with respect to time? What's the derivative of HW with respect to time?
DHW over dt.
Very good. And how about the derivative of RW squared with respect to time?
2R.
2 DRW dt.
Oh.
Everybody's okay? All right, now what? Now it's time to plug in, right? So let's see, what do we got here? We got this, right? And we want to know this, and we got this. But we got some problems here. We got trouble. Big trouble here. Trouble in River City. Do you know RW? Do you know DRW dt? Do we have any way of figuring those out? No. We're at an impasse. We have done something, but we failed to do something because we do not have any information on RW or DRW dt, and we have no means of collecting that information from the information that's given to us. We need to go back to here. We need to find a way to remove RW from our equation.
Why didn't we do that from the beginning?
Well, because I didn't want to, if someone had suggested it at the beginning, we would have. None of you suggested it. You're just like, well, let's do the calculus. Let's plow through. I wanted to approach the problem the way that you guys would have approached it, show you what happens, what that means, and then go back and be like, let's fix it. So we can talk about like what you should notice before you do all that mumbo jumbo and realize that like, oh no. So you don't do that and make that mistake again. But I had to show you what the mistake looks like, or else you don't know what to look for. Do you know what I'm saying? Had to do it this way. I know it's disappointing. All right. How am I going to do that? What? Set it equal to what? Look at the picture.
Oh, Pythagorean theorem.
Mm-mm. No, a good idea, but no. What do you see?
Two triangles.
What kind of triangles?
Right angle triangles.
What can you say about those two triangles?
They are
They are similar. What can we say about two similar triangles?
so
Corresponding parts of similar triangles are proportional. Yes, that is what we can say. I know, geometry, that was a long time ago. But that's correct. That is what we need. That is the second equation that we're going to use to be able to replace our RWs in the other one. So let's write, okay? So I'm going to say that RW over HW is equal to RT over HT. Everybody's okay? Corresponding parts, that's how we build a proportion. So we know what's great about this equation that we've written. We know RT and HT. So I can say that RW is 1/2 HW. Everybody love that? So I'm going to take that and plug it in there, and then make us big again. Everybody's good? We'll clean that up a little bit before we take our derivative. So far, so good. Okay. Now we'll do our derivative of both sides, and everything is going to go just swimmingly. Actually, do that. And HW we're told was 3 in the instant that we cared about. So I multiply both sides by, what is it, 9, or the reciprocal of 9 pi over 4. I guess this is like centimeters per second or something, or minute. So, oh boy, that would be a Ripon faucet if it was per second. 2 meters per second is like crazy. Or 2 cubic meters per second. Like a cubic meter is like, you know, like a box this big filled with water. 2 of those per second is like, yeah, it's like emptying a dump truck on top of you. Like, woof. Okay, so let's go back, and I want to point out to you what I see in the beginning that's going to be a hint that I need to look for a second equation, right? Because that was, nobody saw it, that we were going to need to do that right away. We plowed forward and we got stuck, right? Let's talk about what you would want to look for to know to do this before you get stuck, right? Because nobody wants to do that extra calculus and then realize, oh my God. So when I read the problem, how many derivatives was I given? One that I'm given, one that I'm looking for, right? Everybody see that? When I wrote this equation, if I differentiate this, how many derivatives am I going to get? 1, 2, 3, one for each variable. I have one, I need to find the other. This is going to produce 3. That won't work, right? So if the number of variables in my equation I'm getting ready to differentiate is more than the number of derivatives that I'm interested in, I know that there's got to be an elimination of variable that has to happen. Now, finding that elimination of variables, sometimes I just like, you got to do enough of these to see what it's going to be. So in the cone situation, if your shape is a cone, the similar triangles is the classic trick to eliminate the variables. As we go and we do some more examples of this, we'll pick up some other, we'll see some other situations of what some of the classic geometric trick is. But that's kind of where we're going to stop here for today. Okay. I have some pre-9 questions. You do not need to do these outside of class time, so don't take them. I mean, take them home with you. Don't do any of these over the weekend. What should you do over the weekend instead? Study. Yeah, study for test 3. This will be here waiting for us when we're done with that. This last, what do we have? 10, 15 minutes here. If you would be so kind, why don't you start on this? Do a little bit of work, do a little reinforcement and practice so that you get a little bit in now. No, these are all for you.
Oh, this is all for me.
Yeah, all for you.
Oh.
All for you. There is 3 total pages. Okay, so there should be 3 total pages. I think there are like 15 questions in total here. Oh, it's all yours.
Oh, yeah.
Right.
Or research.
Monday and Tuesday.
Today's Friday.
No, they didn't. Maybe they got.
Lucia,
What?
have you ever looked at test next class?
Yeah.
Oh no.
Oh, and I have a Spanish test that day too.
You can probably get one of those moves if you ask.
Math test.